Okay, everyone, welcome to another episode of Counter Cause. Today, we're diving into something that may, in fact, be a groundbreaking discovery in autism research, one that has the potential to change lives and challenge everything. Joining us today is Dr. Richard Frye, a distinguished pediatric neurologist and researcher who has spent years studying autism, neurodevelopmental disorders, and metabolic dysfunction in children. His work has led to groundbreaking discoveries in how metabolic and mitochondrial function affect children with autism, and more importantly, how we can intervene to help them. Dr. Frye is a former chief of neurodevelopmental disorders at Phoenix Children's Hospital and has authored over 200 peer-reviewed publications focusing on autism spectrum disorders, mitochondrial dysfunction, and neurological treatments. He is one of the leading experts in the world when it comes to autism and innovative medical therapies. One of his most shocking discoveries is that a simple medical intervention, prescription form of folic acid called Leucovorin, could have a profound effect on nonverbal autistic children, helping many of them regain speech for the first time. Thousands of parents have been told that their child would never speak, and yet Dr. Frye's research suggests that that's not necessarily true. So, why aren't more people talking about this? And why is this treatment still so hard to access? We're going to break it all down today. What nonverbal autism is, how leucovorin works, and why there's been so much resistance to getting this treatment mainstream. Before we dive into this, hit that like button, subscribe, hit the bell for notifications, and please, if you have any questions, leave us a comment in the space below. All right, Dr. Frye, thank you so much for joining us today, sir. How's it going?
Good, good. My pleasure to be here.
Okay, let's jump right into it. What exactly is nonverbal autism?
Well, autism varies. I mean, the one of the difficult things with treating and diagnosing children with autism, it's very what we call heterogeneous. It's very different in each child. And one of the things we see that's not uncommon is something called language impairment. And language impairment can happen at every different level, but many times children start out as nonverbal. That is, they don't have any words. They may not say anything. But sometimes they do say sounds. Sometimes these are language sounds or non-language sounds. And sometimes they say single words. And when they say single words, we call it pre-verbal, whereas they haven't developed, the normal verbal techniques. So there's all different levels, but the really important thing to understand is autism is a communication disorder. So we think of language as the way that we communicate mostly, but really what's underappreciated is that many times we use gestures, which is nonverbal communication. And an infant, one of the first ways an infant communicates is not with speech or sounds, but is with gestures, with pointing to what they want. This does not develop in autism. And so we start to understand that it's not just a language, it's that the language isn't being used to communicate, and the child does not know how to communicate. So there's a verbal and a nonverbal portion of this. Of course, verbal communication is very, very important in our society, and we find that not being able to communicate causes a lot of things like problem behaviors, inability to learn, and such. And so, if we can solve that problem and improve communication, we solve many problems with children with autism, and they can start to appreciate therapies. They can start to gain from those therapies because they can communicate with their therapists and then advance themselves quickly.
And I think I've heard before that we tend to overvalue language as humans, and we don't, in terms of, we really put an emphasis on what people say, sometimes how they say it, but there's a whole other facet of language, which is body language, which language experts really tap into. What age does this, and maybe that includes pointing, like you said, in infants. So, what age should parents expect that their children start to exhibit these, symptoms, not symptoms, but pointing or these gestures?
Right. This is a great question. So, one of the problems with diagnosing autism is that autism is a behaviorally defined diagnosis. And so things like inability to communicate and such, the ability to communicate with gestures or language really doesn't start until about the first year of age. So if the child hasn't developed it, you can't say that they don't have it.
Right.
So, yes, the first mode of communication is pointing. Um, it can start as early as 8 months, but usually we see it at about 1 year of age. We think it should actually be intact. It may take time. There's very different types of pointing. There's pointing to what you want, and that's what an infant, a child, a very young starts out with. They point to what they want. And then there's pointing to show you something of interest, which is a more sophisticated social type of pointing. What we find in kiddos with autism is they don't develop pointing. And sometimes they might even develop a little bit of language, but many times they don't develop that pointing. And that's a big red flag that something's going on with communication.
Okay.
There,
And oh,
there's other gestures too. If you talk about nonverbal gestures that that you don't think about, there's also something called showing and giving. And if you ever think, like, when you walk into a room and there's a toddler there, what's one of the first things they do?
they show
A
you
lot
their
of
toy.
times, that's right.
Yeah.
Or they put it in your lap. And that's one of the first social type of communication that there is. And that's something we don't appreciate as much, but it's something we don't see in kiddos that develop autism.
Interesting. And so when they come and show you their toy, that's as much communication as it is socialization in terms of including others, right?
Exactly. They want to share their enjoyment with you. And that's kind of the basis of socialization. And they do that in this nonverbal way by showing you what they have or putting that like in your lap when you're sitting there.
Right. And so both of my kids, I have two young girls. They both started walking right around this year age. Is there some kind of neurological connection between the ability to communicate? And I mean, I know it's motor neurons versus maybe a different type of neuron, but is there a connection between the two that they start to kind of morph at the same time?
Not really, in the sense that many children with autism don't have obvious motor issues.
Okay.
They usually walk on time. They usually sit on time. They tend to develop some coordination issues, but those are more subtle early on. There
Okay.
is a subset of children with autism that do walk late, and don't gain their motor milestones. And those children we suspect, we know that that's a red flag for not only autism but also metabolic disorders such as mitochondrial dysfunction.
Could you explain mitochondrial function a little bit for the audience? I mean, we know that it's the powerhouse of the cell. What the heck does that exactly mean? I mean, this gets into when your mitochondria start functioning improperly, it eventually leads to metabolic dysfunction, which eventually is probably the root of all disease, right? Like diabetes is just a symptom of some form of metabolic dysfunction. So, what is the mitochondria? What does it need? And how can parents give it to their children?
Right. I like to say the mitochondria, although it's known as the powerhouse of the cell, it's you have all these different metabolic pathways. Metabolism is how you make your energy, how you get your building blocks, and how you get rid of the wastes in your body.
Interesting.
So there's metabolic wastes. And the mitochondria, if you look at, they have this thing called the world map, which shows you all of the metabolic pathways. and dead in the center is the mitochondria. So the mitochondria is connected to almost all metabolic pathways. And so if there's any type of disturbance in those metabolic pathways, it affects the mitochondria. And if there's a problem with the mitochondria, it tends to affect those other pathways. So you really can think of it as the center of metabolism.
Okay.
Mostly what it does, we think of, is it takes in fats and carbohydrates and makes them into an energy molecule called ATP, which is the energy currency of our cell.
Adenosine triphosphate, right?
Exactly. And there's lots of sophisticated, chemical pathways inside the mitochondria that do this. So if the mitochondria isn't working, there's many things that happen, but most importantly, your body doesn't have energy, or it tends to run out of energy easily and fatigue. So those are that's one of the signs of mitochondrial dysfunction, although it's not the only sign, and it's not always something that we see. But the neurons of your brain, despite the brain weighing, 1%, 2% of the body's weight, uses up 20% of the oxygen that you breathe.
Wow.
And why is that important? Because the reason you breathe and bring in oxygen is that oxygen is needed for the mitochondria to work. There's a particular part of the mitochondria called complex 4 that uses oxygen. And that's the whole reason you breathe, is to fuel that mitochondria. So the brain is very metabolically active, and the neurons take up a lot of energy. And so if the mitochondria isn't up to where it needs to be to supply that energy, the neurons are not going to work as well as they should. When the mitochondria or other pathways are not working, they need certain types of other, what we call cofactors. And vitamins are a type of cofactor. That's what they are for our body. They need to be used in certain steps, biochemical steps, to convert certain molecules to certain other molecules. If those metabolic pathways aren't working very well, sometimes you need additional cofactors to help the body compensate for that.
And when it comes to, so when we hear energy and we hear mitochondria, a lot of times we hear B vitamins or a B complex. And B12 a lot is associated with energy. It's known that you can't get, like, the body doesn't make enough B12, or it doesn't make it at all. And you can't get it from plants. You have to primarily get it from animal foods, from what I understand. There's a lot of vegans who turn out to be deficient in B12. But what is the B vitamins that you see that children are deficient in that are causing this autism? Or kids with autism, they have a deficiency in which B vitamin?
Right. B vitamins are very important because they're some of the essential cofactors that we use most in the body, although there's other things that are not B vitamins that are cofactors too. B vitamins tend to be some of the most important. Depending on what we see as the abnormalities in metabolic pathways, we may use more or less of certain B vitamins. So it's important to consult, somebody in the medical field, your physician, or somebody with knowledge to help guide you through, which B vitamins you might need. B12 and B9, which is folate, are what I would say some of the most important B vitamins that we have. Now, B vitamins are interesting, and we like them because they're what we call water soluble. And what does that mean? Well, that means that they dissolve easily in your blood and you pee them out. So you lose them very quickly. So you may think that's a disadvantage because you have to keep taking them to have them in your body, but it's also great for safety. So for the most part, B vitamins are very safe because of that, because they don't stay in your body and they will be eliminated, so they can't build up in your body. B vitamins, the major side effect we think of B vitamins is that they cause a lot of energy and excitement sometimes. So sometimes when you add them, you have to add them slowly, or you see a little bit of hyperactivity or irritability.
Interesting. And children with autism, at least the nonverbal autism that you're seeing and reversing, they're deficient in this B9 vitamin folate, right? Um, let's dig into folate, folic acid a little bit. I have this video I want to play for you. There's a lot of info going around from all these gurus on YouTube and whatnot, and they're spewing these things that, like the lay people like me, the parents, it sounds great, but we have no idea if it's true or not. I'd love for you to take a look at this video and just give us your thoughts on it. Stand by.
One of the most common gene mutations in the world is called MTHFR. It's called the motherfucker gene. Stands for methylene tetrahydrofolate reductase, but we call it the motherfucker gene. This gene is estimated to be compromised in somewhere between 40 and 60%, depending on the study. 40 to 60% of the population has this gene mutation. And what this gene mutation does is it interrupts the ability to convert folic acid into the usable form called methylfolate. And while that might not sound like a big deal until you realize that folic acid is the most prevalent nutrient in the human diet. Folic acid, by the way, is an entirely man-made chemical. You can't find folic. We've been lied to about folic acid. I mean, it's entirely man-made and synthetic. You can't find folic acid anywhere on the surface of the earth. It does not occur naturally in nature. Folate does, but we make folic acid in a lab. And then what we've done since 1993 is we've sprayed all of our grains, all white flour, all white rice, all white bread, and grains of any kind are sprayed with this chemical folic acid. It's called fortified or enriched. So when you spin a box of crackers around, it says fortified whole wheat flour or enriched bleached white flour. That means it's been sprayed with folic acid. Well, 44% of the population can't convert that into the usable nutrient.
Okay. That's terrifying as a parent, because when you talk about enriched wheat, that's obviously what they're spraying the breads with. But please, what's your takeaway from this video?
Okay. So yeah, I mean, there are some things that were, that are a little bit not exactly how I would say it. So we want to understand why they would put folic acid in, our breads.
Right.
That people aren't trying to poison us, but we know that one of the things is that folate is very important for health. It's very important to reduce something called neurotube defects in babies while they're growing in their mother's womb. So it's very, very important. So for a way of trying to make the population more healthy, the powers that be said, well, how are we going to do that? Can we add and give people folate? And they said, yes. Well, why don't we put it into certain foods? And then they'll get it through their diet, and we'll fortify these foods. But folate, natural folates, are not as stable, and they're a little bit more expensive to make. So there's a synthetic form of folate called folic acid. And that is what we started to use in our vitamins, fortify our food with, believing that really it was the same thing as folate, as our natural folates. However, we're learning more and more that it's not so, that the body can convert folic acid to folate in the folate cycle, but there's a limit to what the body can convert. Now, the enzyme that makes that conversion is called dihydrofolate reductase. So it's not the MTHFR, but we'll talk about MTHFR in a second.
Okay.
So some people have variations. So when there's a variation in a gene, it's called a polymorphism, not a mutation. And that means that some people are not as efficient as using that pathway. Of course, that can't be a cause in and of itself of disease, or 50% of the population would have that disease, but it does affect how our body works, and we have
Right.
to be mindful of that. And so what we're finding is that folic acid itself, if our body can't convert it, then it starts to build up as unmetabolized folic acid. And unlike natural folates, folic acid, when it builds up, it does inhibit some of the folate cycle. So it's not that great for you. So what started to happen is you can give a little bit of folate and the body will convert it into natural folates, and that's fine. But then, of course, we always think, well, it's good, we should start giving more and more and more. And then we found like, well, we can't really do that with folic acid. And that's not something that was really realized until recently. Once folic acid is converted into folate, it goes into the folate cycle. And one of the first steps is to convert the folate in the folate cycle to something called formalin folate. And that's leucovorin, which we'll talk about later. Leucovorin is very important or formalin folate is very important because what it does is it takes a side pathway, and it's important for making RNA, DNA, neurotransmitters, for breaking down nitric oxide or producing nitric oxide. And so it's very important. But we also have other important parts of the folate cycle. So the next step goes through this MTHFR gene to make something called 5-methyltetrahydrofolate, which is important for the other side of the folate cycle called methylation. And that's where folate works with B12 to make things called methyl groups, which are important for controlling our genes and turning them on and off. So there's many parts of the folate cycle that are important.
And break down, so methylation in its basic sense is you ingest something like protein. It doesn't take that protein and just ship it straight to the muscles. It breaks it down into different amino acids. Is that right? And then from there, the body can utilize the amino acids as it sees fit. Is that close to it?
That's not methylation, but you're absolutely right. That's a whole separate problem. We could talk about the microbiome.
Yeah, we should.
Our body, we'll talk about that in a second, but their body needs to break down, fats, proteins into amino acids, carbohydrates in the gut to actually be brought into the body. Methylation is a special process that's important to make things called methyl groups that are used for many different things. They turn enzymes on and off. They turn genes on and off, right? You have many different cells in your body. So what makes a liver cell, different than a thyroid cell, for example? Well, they both have the same genes. So how can they operate differently? Well, this process called epigenetics uses methyl groups to silence certain genes so that only certain ones are turned on at any particular time. And the very important time that you need these methyl groups, where methylation is important, actually, is while you're growing in your mother's belly. Because in order to make a human, there's many, many different steps that occur very rapidly. And so many different types of genes have to be turned on and off to actually create that human. And if the methylation is interrupted during that time, those instructions won't work right.
Okay, and let's talk about epigenetics a little bit. From what I understand about epigenetics, it's that you're not necessarily your father's or your mother's genetics. Yes, you inherit them, but epigenetics, from what I understand, through you're not subject to the same ailments that your parents were just because you have their genes. Through proper nutrition and through exercise and maybe environment, you can turn these genes off and turn them back on. Obviously, not like you're flipping a switch, but through practice and over time. Am I way off the mark, or is that kind of what it's like?
No, I think you've summarized it nicely. Yeah, depending on our lifestyle, we found out that our body goes into kind of different programs,
Right.
and we want to get it into a healthy program. If it becomes unhealthy, it turns on certain, certain types of pathways that may not be entirely good for us. Such as inflammation. We think of inflammation as a bad thing. We always talk about how we want to reduce inflammation in our body, but inflammation, for the most part, is there to be a good thing,
Right.
right? It's only when it doesn't stop that it becomes a bad thing. So if your body's stuck in an inflammatory mode because it thinks that there's something going on that's bad, then that is not a good thing, and you have to turn that off.
Right. Like if you want to build muscle, you need inflammation, right? Inflammation triggers growth, some sort of anabolic response, and that will help your muscles grow. But there is definitely a time when it becomes too much. And that's kind of what's leading to all this chronic disease is there's no let up in the inflammation, right?
Correct, exactly. And that's why, like, if you're working out and you do a really big workout, you don't want to do a big workout the next day, too.
Right.
And that's because you want the inflammation to calm down, the muscles to heal themselves. And then you go and you do another workout and you go through that cycle. And if you don't let that cycle stop, that's when you can get into trouble.
And this is a little off the topic, but since we're on inflammation, we've been told that if you injure something, you want to ice it or soak it in an ice bath to get rid of the inflammation. But what I think of it as is if you injure something, it's painful because the inflammation is there, but the inflammation is driving the necessary cells to heal it. And so when we talk about heat increases circulation, it increases the inflammation. It may be more painful, but is it reasonable to think that a little bit of heat and inflammation is good around an injury because it focuses more attention on that injury? I feel like if we ice everything when it's injured, we're reducing the circulation, we're pulling the inflammation away, and the inflammation is like the body's natural way of repairing itself.
Yeah, no, it's a good point. So yeah, both heat and coolness are good at different phases of the inflammation.
Right.
You
Okay.
know,
And
so it
we have it
goes like everything. It's not that simple.
right. Yeah, you mean this human body that's been designed isn't as black or white as we make it out to be? That's okay. So let's get into folate. I want to talk about folate, especially we're seeing these autism rates on the rise. This says 1 in 36 children in the United States have autism, which is up 178%. I think before we were speaking beforehand, you said it's up to over 200% now. And 4 times as many boys as girls get autism. Um, Highest rates are in Qatar, lowest rates are in France. United States, obviously on the rise. What's triggering the rise in the autism? Do we know?
Yeah. So the bottom line is we don't know. Okay. But there's two theories that one, it's just better diagnosis
Okay.
that we're finding it more and we're being able to diagnose it better. And the other idea is that it's a true rise. There's something in the world that's causing this rise to increase. And well done studies show that it's a little bit of both. Yeah, we're starting to being able to diagnose it better and see it more, and we're actually seeing more mild cases too because we're able to do that. But there's a true rise that there is because if you look back, 20 years, 30 years, we didn't have these individuals with autism. The rates weren't there, because you can see where are they now, you
Right.
know, and so there does seem to be a true rise. What is this rise and what is it caused by? Well, there's a lot of emphasis put on genetics, but we couldn't evolve. Our genetics could not evolve that fast for it to be a genetic epidemic, and it's not believed there is such a thing. So it can be a number of other different things, and that's what we're looking into. There could be changes in epigenetics, as we were talking about, because of environmental issues. There can be changes in the microbiome that can occur pretty rapidly. We found out that can be driving things, and then we're also learning about these kind of non-genetic heritable disorders that seem to get worse across generations. So there's seems to be many different components to it, and it's quite complicated. And what we do is we look at all of those pieces, at least clinically. What myself and my colleagues do is we look at all those pieces to see how we can maximize their ability to work best.
Okay. And pregnant women, this is just a random study on PubMed in Bangladesh, but it says 38% of enrolled pregnant women were folate deficient. And this also, we can tie this into the gut microbiome too, because we're not getting the necessary nutrients we need through our diet anymore. You go to a grocery store, the entire perimeter is what you probably should be shopping, 80 to 90% of your food, but it only takes up 10 to 20% of the entire grocery. And the center with all the colorful boxes, this takes up 80% of the grocery store, but that's what we see people's carts being filled with. And maybe this ties into infertility rates on the rise too. But is it safe to say that there's a higher chance of autism if you are folate deficient when your baby is in the womb for pregnant mothers?
Right. Yes. Yeah. So, and when we talk about environment, a lot of people think about like toxins, that we're exposed to in the air and such. But the most influential environment you will ever be exposed to is the 9 months in your mother's belly. That's the most important environment.
That's wild.
And yeah, and so you have to, and we're learning more and more about that and really focusing on what's happening prior to birth to really, improve not just autism, but chronic disease.
Right.
And we have a group called the Neurologic Health Foundation, and it produces the Healthy Child Guide, which is really a simple guide for women to help them optimize their pregnancy and reduce chronic disease. Because it's not just autism, it's also allergies and asthma and other things that that seem to be on the rise and can be linked to the intrauterine environment. The intrauterine environment is very important. The child's growing extremely rapidly. The fetus is growing very rapidly. So it needs many of these building blocks, especially folate. As I mentioned, folate is the basis for parts of the RNA and DNA, which are things that need to be replicated very quickly. You have to copy all of your chromosomes to make a new cell, and that takes all DNA. So you have to have those building blocks. If you don't, you're probably going to make mistakes, and that's where mutations come in. And that's what we see in a lot of kids with autism, that they have what we call de novo mutations that have just arose in them. And we know that a folate deficiency could cause that. So we want to make sure women get the proper type of folate. One of the things, if we go back to folic acid, is that the recommendation is to use folic acid. And that's what we have the science on, that giving extra folic acid will reduce what we call neurotube defects and actually reduce autism overall. But then what we're finding is that if you take too much of that folic acid to try and make sure you have enough, you have unmetabolized folic acid. And actually, the amount of unmetabolized folic acid correlates with autism also. So for folic acid, there's just an optimal amount that you can take, and you can't take any more. There's just a certain amount. And this is why we really think that women should be taking more of those natural reduced folates when they're pregnant. Unfortunately, we don't have the science for it yet, and that's what we want to find out: is how much should we be giving? When should we be giving it? But we know that that will be much better than giving folic acid. But women are also deficient in other things. We see iron, we see vitamin D. There's something called carnitine, which is very important, and we see that depleted in individuals when they're pregnant. We know that, at least for vitamin D and iron, that if that's low, that's also correlated with neurodevelopmental issues. So those are all very important. The other thing that we find is that the microbiome, the bacteria that are in your gut, is also associated with chronic disease. And it gets set very early on in life, during the first year of life.
Wow.
And you inherit that from your mother. So your mother's microbiome has to be very good, high quality, so that you inherit a good microbiome, which helps your body grow, programs your immune system, helps your brain grow in other parts of your body.
And Harvard recently produced a study, I don't know how long ago, but it's somewhat recent, that 70%, as much as 70%, if not more, of your immune system is in your gut microbiome. Is that right?
Absolutely true.
So what does that mean? I mean, how can mothers, from what I understand, the more diverse amount of bacteria in your gut, the better for a healthier, stronger microbiome. So for me personally, I will take, and tell me other ways that we can do it, but I'll eat kimchi, which is a fermented cabbage. I will drink maybe like a shot of goat's milk, kefir, because I don't do so well with cow's milk in the morning, and in the evening, just a little something that has a lot of this, Lactobacillus acidophilus in there, these beneficial gut bacteria. I read once that, you read the yogurt that has the bacteria in it, a lot of that bacteria is actually destroyed by the acid in the stomach. And so we need something like kefir, sauerkraut, kimchi, these probiotic enriched foods to really strengthen the immune system.
Right. So it's interesting because, some of these fermented, especially, fermented vegetables are good because not only do they have bacteria, but they're also what we call prebiotics. So to get the right um, bacteria to grow, you need to give it the right food.
A
And we
probiotic
know
is
that.
useless without a prebiotic, right?
That's right. That's right.
Okay.
Because they have to eat something. They have
Right.
to eat the right food. And we know that fiber is very good. Fiber is very good to give to those bacteria that are key to your microbiome. And there's, many different, ways of describing the microbiome. And as you said, diversity, that's absolutely key. We find that disease is associated with reduced diversity of the microbiome. So you do want a diverse microbiome. And then there's certain key bacteria. And those tend to be something like lactobacillus, seems to be very key at keeping your microbiome healthy. The problem with things like certain probiotics is that the bacteria that has to go through the stomach where there's lots of acid, and it may destroy those bacteria. And there are some probiotics out there that are actually protected from the stomach acid and don't open up until it gets past the stomach. So it's important to look for those type of probiotics when you're taking probiotics, because otherwise, it's probably going to be destroyed in the stomach. But the major thing that's really important for keeping a good microbiome is to eat good quality organic food. Right. One of the things that here we keep talking about adding to the microbiome, but the thing we also don't want to do is subtract from the microbiome. So many things, many types of food additives and toxins in our environment and such will actually destroy some of the bacteria in the microbiome. So we want to minimize that, right? So we want to build up the good and reduce the bad, so we have this diverse, healthy microbiome.
Right. And okay, so prebiotics, probiotics. You mentioned something that I want to talk about called carnitine. Sounds like carne, sounds like it's something that's found in meat. What is carnitine? Where do we get it from? And why is it important, especially for expectant mothers? And is it important for young children too? Because, I mean, I talk to a lot of parents that have a lot of issues getting their kids to eat protein. And they're like, well, if you can get them to eat like peanut butter, that has some protein in it. But I don't know that that has carnitine in it. How important is carnitine and what is it?
So carnitine, again, is a cofactor. It's a vitamin that's extremely important. We can get it from meat. So that's one of our major. That's one of the major places that we get it from in our diet. We also can make it to some extent. Again, we only can make so much of it. So sometimes if we don't get it from our diet, we can become carnitine deficient.
Okay.
Carnitine is very important for transporting fatty acids. So it really helps with fatty acid metabolism. But it also is extremely important when there's metabolic abnormalities, because you can think of it as the garbage man of the body. It grabs on to toxic molecules and lets you pee them out. So it eliminates all those toxic molecules. So if you have a lot of metabolic dysfunction, you're going to need more carnitine to kind of clean your body out, and then it can become depleted. So it tends to be a very important molecule too. If you don't have it also, you won't process fatty acids, and they may build up and become inflammatory. So we really want to have a very good level of carnitine. And of course, getting children to eat, is always an issue, but it's always important to understand that they need the nutrition for their body to grow, especially protein, because their body is growing so fast. Protein is kind of the building blocks of our body.
Okay. Perfect. So let's get into now, let's talk about leucovorin and your findings, how you came across it. From what I understand, it's an old chemo drug. Has it been around 70 years or 60 years as a chemo drug? What's it primarily
It's
used
been
for?
around many decades, and some people are kind of scared of it because they hear it's a chemo drug. But what it is it's a drug to rescue the bodies from the effects of chemotherapy.
Okay.
So it's on the good side, not the bad side. It's
Right.
not a chemo drug in the sense that it's something that's going to hurt you. So it's a special type of folate, and it's been around for so long, and we've used it so much. We know how to give it, what the doses are. It's given both orally and when with chemotherapy, it's given IV, intravenously. So we know the doses to be given intravenously. And it's it's very important. The other great thing about leucovorin, because a lot of people ask, why use leucovorin versus like methylfolate, as we heard,
Right.
in the methylfolate. We think it's so important because it is important for methylation, but leucovorin or formalin folate is very important too. So how do we resolve this? Well, the great thing about leucovorin is that about half of it is turned into methylfolate through the gut microbiome or the liver when it's taken orally. So essentially, you get formalin folate, which comes in right before the MTHFR, and 5-methotetrahydrofolate, which comes in right after the MTHFR. So this whole talk about the MTHFR is really null and void, because you have actually two streams of folate that go around the MTHFR and help the body and the folate pathway work as well as it can. So now we can talk about what we see in autism and other neurodevelopmental diseases.
Yeah.
What we find is that folate is deficient or in the brain specifically, not in the body. So for anything to get into the brain, it has to go through a special carrier. There's special, we can think of them as machines that pull nutrients from the blood and bring it into the brain. The brain is a highly regulated, protected place. And we know that these transporters sometimes don't work. And that means that the brain doesn't have what it needs. So this was discovered by a doctor by the name of Vincent Rainmakers, who's in Belgium. And he was trying to figure out why some kids were not developing well. They started to show progressive neurologic deterioration and developed what looked like possibly CP, movement disorders, epilepsy. So what he did, being a neurologist, he actually measured all the chemicals in the individual's brain, and we do that with a lumbar puncture. We can very easily check what the chemistry of the brain is by using a lumbar puncture or spinal tap. You know, you don't want to do it if you don't have to, but in this case, there were no answers. And he found out that this group of kids were low in folate just in their brains. And he kind of thought about it, why this might be. Of course, the first thing he thought is that there might be some genetic problem with that major carrier called the folate receptor alpha that brings folate into the brain. So he sequenced the genes, and he didn't find any differences. So then he teamed up with a scientist by the name of Edward Quatros, who's at SUNY Downstate in Brooklyn. And it ends up this folate carrier is also on the placenta. It also is important for bringing folate to the fetus. And what Dr. Quatros had discovered was that there was this antibody running around the blood of some people that would bind onto this carrier and stop it from working, almost like an autoimmune disease. And so he teamed up with Dr. Rainmakers, and when they saw these kids, he said, why don't we test to see if they have this antibody? And it ends up that, about 90% of them did. So they think they had what they had found is one new disease called cerebral folate deficiency, and this biomarker that shows why folate is not getting into the brain because this antibody was running around the blood. And the first paper was published in the New England Journal of Medicine, which is one of the best journals in the world, in 2005. What we had noticed, though, is that after this was discovered, more and more people would start publishing case studies of other patients they found, and they all seemed to have features of autism. Many of them had features of autism. So myself and my colleague, Dr. Dan Rossignol, said, well, how many of these kids are running around our clinic that have this antibody, and it could be contributing to their autism? So we did our first study by offering this test to patients in our clinic, and we found that 75% of the kids in our clinic with autism had one of the two antibodies that Dr. Quatros had discovered, which is the blocking antibody and the binding antibody. So we figured we were onto something. So one of the ways that they had shown that you can treat this is with leucovorin, right? We knew leucovorin was very important for getting around this block because of how it's been studied in cancer. Dr. Rainmakers had published a paper of just a few patients where he showed that he almost normalized their symptoms by giving leucovorin. So what we did is we offered leucovorin to the children or to the families with children that were positive for this antibody. Some of them we also did a lumbar puncture to verify that their folate levels were low in the brain and the CSF. But we felt that leucovorin was safe enough that a trial of it for a short amount of time was also appropriate too, if you did not want to go through the lumbar puncture,
Right.
since that's a very big procedure. And what we found is that compared to what we call the waitlist control, and those are children that are waiting around to get results of their folate autoantibody test, compared to them, these children that received the leucovorin improved dramatically in language, expressive language, receptive language, and verbal communication. And they also improved in hyperactivity and stereotyped behavior. We used a standardized questionnaire where the parents could rate how these symptoms got better or worse, so we could compare apples to apples. So that was our first study. That was our first open label study, and we published that in Molecular Psychiatry in 2012.
Amazing. And okay, so I want to talk about the problems, not problems, but the hurdles that you have to go over with leucovorin. It seems to me that it's being used as a drug which is called off-label, which is for a purpose other than its intended purpose. And so it doesn't have FDA approval. What does that mean for parents? I mean, and what does that mean for funding? Is it difficult to get funding? I mean, it's a drug that's been around for 70 years. We've heard this, these criticisms about ivermectin, that the issue with ivermectin is there's no money to be made, so there's not a lot of investors in it. Is this the same thing with leucovorin, that it's one, it's off label, and two, there's not a lot of money to be made?
Right. I mean, it is used off label, and that means when you go to get a drug approved, you say, I'm going to use it for this disease. But many times we find that drugs are useful for many other diseases, and that's
Right.
called off-label use. It's important to have the studies to back you up, when you use things off-label, and know the limitations. But what we'd love to do is have it as an indication for autism, because many doctors are not comfortable using drugs off-label if they don't understand the mechanism, and that's fair.
Yeah.
They hear it's a cancer drug. That's what they remember from medical school, and they're like, I'm just not comfortable, with this, And so what we want to do is make sure that it's indicated. So we hope that it will be one of the first treatments that children get when they're diagnosed. We've seen such improvements in some children that we believe that it would be best. One of the best things is when they get diagnosed to test them for this folate autoantibody, and if appropriate, give them leucovorin, because it may help them with all their therapies and help them recover very quickly.
And
One
is
of
this
the problems,
Oh, sorry, go ahead.
yeah, as you say, one of the problems is that something that's already a drug that's out there, you can't make money on it. And so venture capital, and others and pharmaceutical companies aren't very excited about putting money into the development of it, because they're not going to get much money back. And they're in the business of making money. That's how the system works, right?
Right.
So you can't blame them. And so, when we need to find ways that we can do the studies so we could fulfill the criteria for the FDA. The FDA is not blocking us. The FDA has been very receptive, to this, because they want to find a treatment for autism too. But they can't do the studies for us. They don't have the money to give us to do the studies. So it's up to us to fulfill what they believe is needed to make sure that it's a safe and effective medication.
And you have to find the funding so you can do the research so you can get the FDA approval. It's kind of that ladder that you have to climb up.
Yes. And then there's another issue is that to change the indication or add an indication to a drug, even if we did the studies, we can't do it. We have to go back to the original pharmaceutical company that got the original indication and have them do it. So we need their cooperation too.
Oh my goodness. And that seems more of a hurdle, more of a pain for them to do because they've already moved on 50 years from now to something else that they're working on.
Plus, if it's already being used off label, there's no advantage to them to actually get a new indication because that causes more liability, right? Because they've said it. So, so it's complicated. So what we're doing is we're using a new type of leucovorin called L-leucovorin or levoleucovorin. And what that is, it's the isomer of the molecule. So each drug molecule that you take has two mirror images. And one is the active form that does the work. And there's the other that doesn't do too much else except maybe, cause side effects.
Right.
So it's some drugs, we isolate just the active form. And that's what we have in the levoleucovorin. And we're continuing to do studies. And we want to try and get the levoleucovorin as an indication as we're working with a drug company in Switzerland that is producing this. And they're very excited about getting an indication. The good part of that, of having this levoleucovorin, is that many of the commercial brands of leucovorin have additives in them that are very disruptive in some kids with autism. And we've started to learn which are the good and the bad brands, but it doesn't mean they're going to stay that way. The companies can change what the ingredients are in any drug at any time. So we want to make a type of leucovorin that's very clean and can be given to children very easily with autism and make it easy to surmount all these hurdles.
The drug companies can change the ingredients at any time for any reason. This has to be non-active ingredients, I'm assuming, right?
So these are called incipients.
Incipients.
Right. Yes, they're additives to the drugs. There's a long list of them. And they're thought to be...
Like what's an additive? Red, we talked about in the past, red dye, you said, right?
Yeah, red dye can be an additive. Many of them have some lactose in it, and we know a lot of kids are lactose intolerant.
Yeah.
And maybe that little bit of lactose doesn't bother some kids, but other kids it might that are very sensitive. And so the FDA has a list of incipients that you can use that are approved that are supposedly benign. And at any time, you can change which incipients you use as long as they're approved.
Without having to notify
anybody? You don't
anybody?
have to change labeling. What's that?
You don't have to notify anybody either?
You don't have to change the labeling, we know. You
Right.
probably have to tell the FDA that you're doing it, but as long as it's a list of approved excipients, there's no reason to say that you can't do it.
And is it quite possible that a high percentage of the adverse effects that people experience from prescriptions comes from these incipients? Is that reasonable?
It is. There was a study about 5-7 years ago that looked at adverse effects from medications, and they estimated that 50% of the time the adverse effects was from the incipients, not from the drug itself.
Geez, how serious can how serious do the effects range from these incipients? Is it serious? Is it, mild? What is it the gamut? What is it?
I think it's the gamut, but sometimes we can have extreme drug allergies, and whether that's to the drug or the excipients, we never really test that out.
Right.
It can be depending on how people react, it could be serious in some people. But the fact is, we think that they're benign, but we find that they're not benign in some individuals. Yeah.
And this leads me to get into the discussion of which I believe you're an advocate for, is that there is no blanket cure, there is no blanket treatment that works for everybody. I mean, sure, things like antibiotics have a high percentage rate, obviously, of killing bacteria, but they're going to affect people in different ways because the way people operate once all that bacteria is destroyed is vastly different. So, what's our approach moving forward in your eyes in terms of, is there a cure-all? Is every individual need to be treated as such, an individual? Tell me about that.
Right. No, thanks for bringing it up. Yeah, we definitely advocate for a personalized precision care type of approach. And that's why we try and use biomarkers like the folate autoantibody. So one of the first things we do is we do the test that will tell us something and guide us to treatment of that individual, because otherwise we're kind of guessing.
Right.
And everybody is different. And we really need to have those markers that tells us what's particularly different about this person versus the other person. Their symptoms may show up the same way on the outside, but what's going on inside their body so that we can personalize their therapy. And for example, you say, antibiotics. A lot of times we don't like to use antibiotics too much because they can disrupt the microbiome.
Right.
So it'd be important to know before you give somebody antibiotics if there's somebody that has, a disrupted microbiome, because you don't want to make it worse.
Is it possible to, I've heard that in terms of antibiotics, I don't want to get too far off topic, but when you ingest antibiotics, they don't discriminate against bacteria. So they kill the good bacteria, they kill the bad bacteria in the gut. Does this allow the fungus or the mycotoxins in your body to proliferate more because it disrupts the balance? Is that possible?
Right. So you could get fungal overgrowth as a consequence of that if you destroy the good bacteria. And so different antibiotics, have different effects on different bacteria. So you could customize which antibiotics you want to give. And, the fungal overgrowth, well, that's probably not going to happen unless you have a really weak microbiome and then you give an antibiotic. If you have a strong microbiome, it can actually stand that antibiotic, and the number of bacteria that are destroyed that are good probably won't make all that much of a difference because it's a robust microbiome. And this comes back to the complexity you said, this complexity, diversity of the microbiome. You can think of it as a forest. The more plants there are in the forest, the more robust the forest is.
Right. And would it be, let's, about pregnant mothers, the CDC has estimated, I think, something like 66 million of the 240 million prescriptions back in 2022, antibiotic prescriptions, were deemed unnecessary. What's your recommendation for expectant mothers, pregnant mothers who may go into the doctor's office and an antibiotic is on the table? Would you say stay away unless you absolutely need it? What's your recommendation there?
Yeah, that's a really tough one, because the other side of the coin is we know that one of the things that is a risk factor for autism is inflammation during pregnancy.
Oh, okay.
So, and so this is where medicine becomes dicey, right? We have to look at the good and the bad of it. So a antibiotic may be, very necessary, but it's just important to look carefully that it's actually needed, because you're absolutely right that many times we give antibiotics just because it's more of a convenience factor, right? You come in and you have a cold, and probably it's viral, but the doctor wants to make sure that you get better and you don't come back, so they give you an antibiotic just in
Oh,
case it's
geez.
bacterial.
Yeah. And when my wife was pregnant with our first baby, I remember she got the blood tests, and we eventually had to get the RhoGAM shot. But I remember the OB coming back in and saying, "You have E. coli, by the way." And she had E. coli, but had felt no symptoms because the fetus or the baby blunted those symptoms. Is that actually a thing?
It could be because your immune system is somewhat suppressed during pregnancy, right? Because you have a foreign organism inside of you. So
Right.
you don't want your immune system to attack it. So yes, there are some
Ah.
changes, and that could be the case.
Okay, awesome. Well, doctor, I don't want to take too much of your time. I do want to inform the audience you have a PhD from Georgetown, you have an MD from Harvard. Oh, he's done. We lost him. Is he coming back in? What happened to the feet? Anyway, Dr. Frye has a PhD from Georgetown, an MD from Harvard. He's been the director of the Arkansas Children's Hospital, the director of the Phoenix Children's Hospital. Um, and it was so great to have him on. I don't know what happened to the feed here with him. Let me see if we can get him back real fast. And stand by. Anyway, we want to thank Dr. Frye for his time on the show. If you want to learn more about it, we're going to post all the information about Dr. Frye in the description below. Please like the video, subscribe to the channel. Let me see if we can get him back. No, we still lost the feed on him. Let me see if I can get him back still. Stand by. Dr. Frye, can you still hear me? He can still hear me, but I'm not getting him. Okay. Anyway, we lost the feed. Dr. Frye, this has been an incredible discussion. Thank you so much for your time on the show. I think it's such a valuable insight for all the people. If you want to learn more, like I said, in the description below, and we'll see you guys on the next one.